Today we are going to model with quadratic functions, and the big thing that we're going to learn today is if we have a vertex and a point on the parabola, we can use vertex form to write an equation for the parabola. If we have a point and the x-intercepts on the parabola, we have enough information to write an equation for the parabola. So that's what we're going to start with, and then we'll talk about kind of identifying how the different points on the graph are going to help us in solving problems. So example 1, we are going to write an equation using a vertex and a point. So we are going to use vertex form. The graph shows the parabolic path of a performer who is shot out of a cannon, where y is the height in feet and x is the horizontal distance traveled in feet. Our first thing we need to do is write an equation of the parabola. So this guy is going to stand on this platform right here in a cannon and be shot out of the cannon. After this guy has gone 50 feet horizontally, he will be 35 feet high. And later on, we're going to actually figure out when he lands in this net over here, how high up is that net. So first of all, writing the equation of the parabola. Because we have the vertex on this parabola, we are going to use vertex form. So I'm going to write what vertex form is on the problem. The vertex of this parabola is 50, 35. That means 50 is the h and 35 is the k. So your next step is to put 50 in place of h and 35 in place of k. Ultimately, what we're trying to figure out is what is that a value going to be? Right now we have 3 unknowns. We don't know y, we don't know a, we don't know x. That's too many unknowns. But we do know a y and a corresponding x because we have this point, 0, 15. 0 is an x value, 15 is a y value. That's an x and a y combination that definitely work in this equation. So we're going to plug in 15 in place of that y. And we're going to plug 0 in place of the x. Now we only have one unknown. And if you have one unknown, you can solve. So I'm going to start inside the parentheses because PEMDAS says that's what I'm supposed to do. So 0 minus 50 is negative 50. Negative 50 squared. What is negative 50 squared? So we have a times 2,500 plus 35. What should we do next? We should subtract 35 from both sides. That will give us negative 20 equals a times 2,500. And I'm going to tell you right now we're skipping example B, so we can just continue our work underneath example B. To get a by itself, we would need to divide both sides by 2,500. Once we figure out that a is negative 0.008, notice the problem does not say find the value of a. The problem says write an equation of the parabola. So I'm going to go back up to this step where we had the equation pretty much all the way written except we didn't know what a was. Now we know what a is. So we can rewrite this. Y equals negative 0.008 times x minus 50 squared plus 35. That is the vertex form of this parabola. Next, the performer lands in a net 90 feet from the cannon. What is the height of the net? So this point right here is 90 comma something. 90 feet horizontally into this flight, he's going to land in this net, and we want to know how high that net is. Now, we could look at this graph and we could estimate, but we don't need to estimate because we have an equation. We can take x equals 90 and plug it into our equation. So grab your calculators and plug that in. Negative 0.008 parentheses 90 minus 50 squared plus 35. .2 feet. Feet high, correct. So 90 feet horizontally into this flight, he lands in a net. That net is 22.2 feet. And you can use the graph to check yourself. Does that look like approximately 22.2? Yeah, that would work. The other things that are interesting to notice, I want you to understand what these points mean in relation to the real world situation. So his starting point is 0, 15. 0 means he hasn't done any horizontal distance yet. 15 means he's starting on a platform. That cannon is 15 feet high. So he's starting 15 feet up, and then he travels in this arc shape. He makes it to a max height. Remember, the y value of the vertex is a maximum height. His max height is 35 feet, and then he lands in a net at 22.2 feet. Okay, now overall, was this problem all that difficult? Plug in the vertex, plug in the point, figure out what A is. Once you figure out what A is, go back and rewrite the equation with your A value. Okay, let's go down to example 2A. Write an equation using a point and the x-intercepts. A meteorologist creates a parabola to predict the temperature tomorrow, where x is the number of hours after midnight and y is the temperature in degrees Celsius. Now we're going to talk about what this sentence means. Write a function f that models the temperature over time. We'll talk about what that means when we write our actual answer. But ultimately, it's x-intercepts, so we are going to use intercept form. So I'm going to start by copying intercept form into my example. The x-intercepts on this parabola are at 4 and 24. So our first step is to put in x minus 4 and x minus 24. So replace the p and the q with 4 and 24. We currently have 3 unknowns. We don't know y, we don't know x, we don't know a. We want to figure out what a is. So this other point is an x and y combination that works in this parabola. So we're going to put 0 in place of each of these x's. Leave the a in there because that's what we're trying to figure out. And 9.6 is the corresponding y value. Again, we are not going to do example B, so we can just continue your work below this. So 9.6 equals a times -4 times -24. The order that you multiply things doesn't matter. So we can do -4 times -24. Does anyone know what that is? 96. So 9.6 equals a times 96. How do we get that a by itself? Divide by 96. Is it positive 0.1? Okay. Now again, it does not say find the value of a. It says write a function, write the equation. So go back up to where we had our intercepts plugged in, and now we know what a is. So we can rewrite this using our a value. This is really annoying me. y equals 0.1 times x minus 4 times x minus 24. Now the language that they use, they're saying write a function f that models the temperature over time. They really want you to write this like f of t equals 0.1 times t minus 4 times t minus 24. But whether you write it in function notation or in y equals, I don't care. For me, the important thing is that you understand how to take this parabola that gives you the two intercepts and a point, and that you can write an equation from it. I don't care what form you put that equation in, just get the equation written. The second part of this, we aren't actually going to do this, but I want to talk to you about it. What is the coldest temperature? Where on this parabola is that number going to be? The bottom. It would be the bottom wherever the vertex is. Now on this graph, it sure looks like it's going to be negative 10. But if we really wanted to be sure, we would need to take our intercept form steps, find the vertex of the intercept form. So find the average, the middle point between 4 and 24, and plug that x value in to figure out the corresponding y value. If you know how to find the vertex of intercept form, you would know how to answer this question. I'm pretty sure it ends up being negative 10 or something really stinking close to negative 10. If this was an ACT test and they asked you that question, look at the graph and estimate and pick the answer the closest to what the graph estimation would be. If it's not an ACT test, you would actually have to, between 4 and 24, is that what, 14? And then plug 14 into the equation and figure out what you get.